All right, today we're looking at graphing square root and cube root functions. So, one thing I'd like you to try is to graph these on your graphing calculator. The square root of x, 2 times the square root of x, and negative 3 times the square root of x. So what's happening there as we are changing that a value? So I'll give you some time to pause the video, work through, do that, and then go ahead and check it and come back and do the same with set 2. Pause the video, look at the cube root of x, 2 cube root of x, and negative 3 cube root of x. What you should notice is that all of these graphs start at 0, 0. They all go through the point 1a. So that means on this first graph, the a is 1 here. So your graph is going to go through 1, 1. Whereas on the second graph, if it went through 1, 1 the first time, then it's going through 1, 2 this time. And then on the third graph, if it went through 1, 1 up there, it's going through 1, negative 3. So it's going the opposite direction since we have that negative. Here's your parent function, a times the square root of x. What you should notice is something similar is happening with these cube roots, except we're going through 0, 0, 1a, and negative 1, negative a. So you have 3 key points there, but it behaves very much the same in that it's stretching out vertically when we're adding those a values in there. Transformations. Transformations are going to function very much the same as they have with the other functions that we have been doing. So that minus h plus k, that h value is going to tell you how far to the right it translated, and that k value is going to tell you how far up it translated from that original parent function of a square root of x and a cube root of x. So how would you obtain the cube root of x minus 2 plus 1 from the cube root of x? Well, we would have moved to the right 2 and up 1. So let's try graphing some of these. So graph the parent function and then shift the graph accordingly. So our parent function here then would be y equals 2 radical x. So I'm going to go ahead and put in some points here. So if I'm thinking square root, I want some nice values. So if I put 0 in, square root of 0 is 0 times 2 is still 0. If I put 1 in, square root of 1 is 1 times 2 is 2. I'm going to put 4 in because the square root of 4 is 2 times 2 is 4. If I put 9 in, the square root of 9 is 3. 3 times 2 is 6. So then my translation would be to move to the left 4 and down 1. I'm going to use blue here for this so I can graph them. So from 0, 0, I'm going to move left 4, and I'm going to move down 1. From 1, 2, I'm going to move left 4. So 1 minus 4 is negative 3. 2 minus 1 is 1. 4, 4. 4 minus 4 is 0. 4 minus 1 is 3. 9, 6. 9 minus 4 is 5. 6 minus 1 is 5. So what I want you to notice is we went through 0, 0, and 1A on that original graph. So we go through 0, 0, 1, 2, 4, 4, 9, 6, so there's my parent function, and then here we have negative 4, negative 1, negative 3, positive 1, 0, 3, and 5, 5. Okay, it also said to graph the domain, or to state the domain and range. So for my original one, domain, what am I plugging in? Well, I'm not plugging in anything smaller than 0. So 0 all the way up to infinity. For my range, again, I'm not going to get anything smaller than 0 out, but it does go all the way up to infinity, and you can see that represented in the graph. In my new function, then, the smallest value plugged in is negative 4, and it goes all the way up to infinity. And the smallest value we're getting out is negative 1, and it goes all the way up to infinity. So graph negative 2 cube root of x minus 3 plus 2, state the domain and range. Let's go ahead and graph our parent function. So y equals negative 2 cube root of x. From there we'll move right 3 and up 2. Okay, so we had 3 points then that we can do without even plugging those values in. We had 0, 0, we have 1A, and we have negative 1, negative A. And so the opposite of negative 2 is positive 2. Then we translate, so write 3 up 2. Looks like that, and we can plot both of these on the graph. So 0, 0, 1, negative 2, negative 1, positive 2. It's important that you know what these graphs are going to look like so you can picture that, and as long as you can, you don't need a ton of points. So then 3, 2 is that center turning point for me on this translation. Looks like this. All right, let's talk domain and range. So domain of our original. Well, it looks to me like there are no restrictions. I can plug anything I want into the original, and I'm going to get any value out. So that means when we've translated it, there's also no restrictions. So negative infinity to infinity. Or all real numbers on both of these. Alright guys, that's all I have for you on this set of notes. So if you have questions, come in and see me. Otherwise, I'll see you in class.